thank you for for coming, by the way, because this is like hidden from the whole conference, and it's not as easy just to walk into one of those rooms. So I do appreciate you taking the time and walking a little bit all the way here. Um, all right, so we can at least start with the introduction of this. This is gonna be a presentation about diving into some of the workflows that are possible with Flocky. And Flocky is built on the top of Dapper. And I'm going to explain a little bit what that is in a couple minutes. And of course, just before I say anything, this is not a presentation that I'm doing for Microsoft or with Microsoft. I'm actually a cybersecurity researcher who has been very passionate about AI for the past like 2-3 years. And now my career is actually going in that direction at the moment. So everything that you guys are going to see here is just a lot of the research that I've done on my own, and also sharing a few things internally with with a couple of friends also in the company, right? But just in case I don't represent Microsoft in this presentation. And let's just go straight to what Flocky is, right? Because I know that just by the title, a lot of you might have been like, what's going on with this presentation? Flocky, first, I'm a big fan of the Vikings series. And I love the character Floki because he was a really hands-on person. He could build boats and he could actually enable other Vikings to travel, right? So that was kind of like the idea of building something that others can use and actually build their own tools on the top of that. And think about Floki as an agentic framework that you can use to build applications like LLM-based applications. For those that are already in the field or curious about AI and how it applies in multiple topics, you might have heard of libraries like LangChain, for example, or like Llama Index, or Crew AI, etc. Floki is my own interpretation into what I believe an agent needs. I'm trying to keep it as lightweight as possible, even though it already has a lot of multiple things, but my goal was to learn the internals of the tool and exactly how everything works. I actually just remember my journey when I was trying to learn into like how an agent communicates with with APIs, etc. And so Floki, it's like the first milestone to build something after reading about it. And the big thing with Floki is that, to me, when I saw all these other applications, it was not as easy to build workflows, right? To chain actions or build things that were driven by other events, or try to integrate a human in the loop, for example. It was not as easy. It is still not as easy. Like if you actually see a workflow with LangGraph and a workflow with Llama Index, you have to really become kind of like an expert on those two tools in order to build one. So Floki is kind of like, let's make it easy. Let's build workflows that are super easy to understand and follow. So hopefully this is a tool that you will be able to use at some point. And let me know. It's already in GitHub, and it has been already 2 months since I released it. All right, just to start, who's familiar with agents in the audience? Anyone that? All right, so you guys all know what an agent is, all right? So, but in general, right, think about this application where the user is interacting with an LLM or just a language model. And then this model is the one that is doing a lot of the thinking. Some people say it's not reasoning. It's just predicting, right, the next word. But a lot of the knowledge and context that it has, it kind of produces output that it's super interesting, and it looks like it's actually thinking, reasoning across different tasks. And the idea is that the very basic idea is to help the human or help itself to choose the right tool or the right next step to take. Sometimes this can come with a predetermined plan that it was able to produce, or in some scenarios, just go one step at a time and try to just pick the right thing that it needs. And then, of course, the model doesn't execute any tools. The model just suggests the tool and suggests how you can execute the tool. And then you have to take that context and then execute it yourself, right? And the idea is that with this basic flow, you are exposing a model to the world, right? You're allowing it to get observations from different environments depending on the scenario that you're using this agent for, right? So think about that. That's just the foundations. Very basic, I guess, way to explain an agent. And when we start thinking about this agentic flow, right? So this, to me, technically, you can use it like this, where you want some type of input, where you provide some input. You want this thing to reason, to act on it, and also to observe what happened, and then let you know, right? At the same time, you can add some loops. So you can say, hey, let's probably give it another try, right? I don't think this is what I needed. Why don't you go again and do the whole loop? And at the same time, you can pretty much have this loop sometimes set to like 20 to 100 different times, or you can just probably let it run right multiple times. So every time you think about an agent, there is some type of flow already integrated, and there is different agentic patterns that follow some type of flow, right? Now the cool thing is that in some of these steps in the flow is when you have the model that is actually doing something, right? So in this case, when you are asking it, let's say to reason, the model is at that step. When you want it to act, once again, the model doesn't act. So it's very important to understand also in what part of the flow you're actually using the model, so that you can probably integrate it with with other tools, etc. And the tools, of course, are set, I guess, on the act part, and the observations is anything that it's able to gather from the world or from the environment that it is, like kind of operating on. So when you think about, the agentic patterns, right? So the first one that we talked about here, this is just your basic reflection type of loop, where it's taking the task, is reasoning over, executing something, trying to reason, providing some feedback into like what happens, and then it just goes back right into that loop. Then of course you have the tool use, where you're adding tools for it to use in order to act based on the reasoning, right? You can actually add some planning also. So this is very interesting pattern, because to me, in some scenarios, like in cybersecurity, for example, you cannot just plan the whole investigation, because the investigation usually you start with an alert and you're trying to figure out what happens next. So you might have a plan that might say, at a high level, this is what I would do, but you know what? This plan might need to become a different plan in the next couple of steps, but at least one plan is good in order to cover maybe the fundamental steps that this system can take, right? And at the end, of course, you can take all these patterns, and you can kind of encapsulate them in like one microservice, and then that thing can actually interact with other microservices that have their own patterns, right? So when you start thinking about agentic patterns, there is always a workflow under a capability that this agent or this application has, right? And to me, a lot of people talk about workflows as, for example, if it's deterministic, it's not an agentic workflow. Or if it's non-deterministic, it is an agentic workflow, right? But in my experience, you mix it up for a lot of different things. There's going to be places where it's going to be very deterministic, places where you want it to go in directions depending on what observations it's actually acquiring. So it's very interesting to think about this type of flows. Who has heard of React patterns? Yeah, so the reasoning or reason and act is pretty much what I was showing you initially. It's just a way for the agent to be able to reason over the task, be able to act, and then simply just go in that loop. And that at the end is just a basic workflow once again, right? So when somebody says an agentic pattern, a React agentic pattern, and then you see this flow, it's very basic, right? So when somebody says agentic, you have to start thinking about that something like that is agentic, apparently, right? There is other complex type of workflows that you might experience as well. And there is a big debate also at Microsoft, what, in my opinion, based on my team and other interactions, that the agents, I'm not here to sell anything, right? But the Copilot agents, and sometimes I think about it, I say, that sounds to me more like a chatbot, but there's a lot of connections probably somewhere else where there is some agentic workflows going on. But anyways, it's a very interesting concept, and to me, I like to dive into like what's going on underneath and not worry so much about calling it agentic or not, right? So the idea of React would be something like this. So this is something that, I don't know if you can see it, but this is something that we can do with Floki, for example. As I mentioned before, Floki comes with a lot of the basics of initializing an agent in Python, and then you can simply give it tools and then make it just reason over the task and then use the tools, right? So nothing crazy in here. Now, what is Dapr? So for those that have never heard of Dapr, right, it's a distributed application runtime. And to me, this is one of the projects that, to be honest, I've been so happy about for the past couple of years. And the reason why is because every time I want to build something, right, there is an API that I need to start interacting with. There is a new module that I need to write to communicate with a Key Vault, with an Azure Cosmos DB, with an AWS instance. Right? There is a lot of different resources out there that I don't have the time to start building all of the connectors that exist in the world. So when you start thinking about LangChain and Llama Index, that's what they do, right? They actually separated a library to say core LangChain and then community LangChain because of all the connectors that they want to have. And to me, it's just crazy to even think about, like, if I go from a resource from Azure and I move it to AWS or GCP, I have to change my code. I have to probably have different parameters. It's just a pain in the ass. Right? So Dapr kind of like comes with this concept of a sidecar that it's already acting as a proxy for you. And there is already a lot of different connectors and integrations for specific services, right? So as you can see in here, you can do workflows, you can access secrets. And what I mean by that is that if I write code to access a secret from an Azure Key Vault, I don't want to rewrite it or import another thing just to, talk to the equivalent in AWS. Dapr as a sidecar gives you those APIs so you don't have to worry about what it is that you're integrating with, right? So that's something that I like about it, and it's also, platform agnostic, and it comes in different languages: Python, C#, what else? Node, Node, Java, etc. Right? So one of the components that Dapr has is Dapr workflows, and this is actually built on the top of durable tasks. So if you have heard of that concept of a durable task in Azure, it's actually what it's running, I would say, on the orchestrators and workflows of like Azure Functions, for example, in Azure. So they open source a lot of their SDKs, like Python. I think there's also Go SDKs, and Dapr is the core components are written in Go. But this one is the one that, to me, when I saw it, this is pretty cool. 2023, I was trying to build things with this, and it was not as good. It was not as stable, but now it's way better than what it was in 2023. And the idea here is that I want to define my workflows as code. Like, I would love to do a basic for loop, a while loop, a conditional statement without have to worry about, wait, how do I do a for loop with this? And that's what I experience with other libraries. Once again, I'm not trying to say don't use LangChain, LangGraph, and use Flocky. I'm not saying that. But if I go back to LangGraph and all these things to build basic workflows, I have to learn so many different new things, and I don't have time to do that, to be honest. So I just wanted to work with something that will make it easy to deploy in production and also be able to test everything locally and just define my workflows as code, right? Or just as a basic, I guess, Pythonic, way to do it. So the workflow patterns that Dapr comes with are very basic, task chaining. It comes with a fan out, fan in, and also with the concept of like monitoring. So what that means is that you can have this while loop, and also expect an event to occur in order for you to do something with it, right? So even though this is super basic, right, you can build so much with these 3 patterns. And if you start looking into multiple blog posts out there to build the next agentic RAG and the next workflow to even build a podcast, you can do the same thing with these 3 things in here, right? And the idea is that some of them can be just multiple LLM-based, tasks, right? Or you can wrap a whole agent into it, which will have its own little workflow inside, and you can just make it communicate or simply be able to be part of every single step. So the difference is that I could say, can you write an email? Can you define maybe the sentiment of the email? Can you fix the email? That to me is just trying to do LLM, based like API calls, or it's just me doing ChatGPT what I'm expecting just to do something for me right away. One agent could be, hey, can you, I don't know, query all the alerts in my environment and maybe just connect to other instances, other services, and maybe do some other things. So now this thing just goes, and with the right access, we'll just start, going through the process, reasoning, executing tools, etc. So that's what I mean by having an agent versus just an LLM-based task, right? And of course, when it comes to monitor, you can monitor a set of agents, and one capability, of course, that you get with Dapper is that you can connect with services that make it easy to share messages. And that's also something that, in my opinion, services like Dapper and any other probably frameworks that you probably have heard of that are similar to Dapper, they have already figured it out, right? They already deploy things in production to do this type of message sharing, etc. So when I see a lot of other frameworks trying to rebuild it, like the ones that I already mentioned, it's just so frustrating, right? Because it's already there, right? They already connect with all the things that will make it happen. So at the end, that's what Floki is, a tool that not only provides the fundamentals of one agent, but it actually allows you to take that agent and convert it into a microservice and also have it exposed as a fast API server, and then it's able to communicate with other microservices through message systems like pops up, right? Like publish and subscribing, right? So that's what Floki is, and if you give it a try, please let me know. I've been fixing a lot of bugs recently. I'm the type of person that if I release a project, it has to be perfect, but that will never happen. So I had to release it in November. It's funny because I always bring my wife into this because that's the only person that I talk to seriously, like every day, because I work from home. And she's like, you have to release it. Like there's no way that you're gonna be working on this for the next year or two trying to make it the best project ever. So that's what I mean. If there is bugs, I'm sorry. It's still an early project, but hopefully you guys can give it a try. So now think about that. If you now have an agent, by default, like out of the box, right, when you deploy it as a service with Dapper, right, you will be able to directly, if you do Dapper init locally, for example, you will have locally multiple Docker containers that will provide several capabilities that are amazing when you start building, in my opinion, agents. Not necessarily to see what the API calls were, like the messages. There is other applications that I use for that. But to figure out how the orchestration is happening, how much time is taking every single step, this is amazing. And can I keep the state of my agents, for example, somewhere? You can do that with Dapr automatically because they already have an API where you can simply say save state and then you pass a dictionary. So instead of me trying to build the whole thing, it's already there. So very simple, and the concept in here is pretty much saying that all the agents that you probably want to build will already come with a lot of different integrations right now. And this is what I was talking about. If I build an agent, in my opinion, and I wanted to interact with multiple services, right? I don't want to build the connectors. No way, right? There is even things that I've never heard of in here, to be honest. And you guys probably already know a lot of them, but for example, what is the one that I was looking at the other day? Oh yeah, there's this one right here. The open policy agent, to be honest, I have never heard of. And I thought it was another agent, like another AI agent, but it doesn't seem to be. But this is what I'm talking about. So if someone says, oh, the organization wants us to build something with Redis and connect with Azure Cosmos DB or Key Vault, right? Or use Kafka, for example, for like pops up, you don't have to worry about that anymore, right? So that's the beauty of Dapper and why I built Floki on the top of that, right? And the idea now is that you will have multiple agents that will communicate with each other through those services, right? So that's pretty much what but this is. And I just want you to pay attention on the sidecar, right? So the idea is that the sidecar is the one that will expose a lot of these capabilities. And at the same time, when you execute something, it's already capturing telemetry because the sidecar is present in front of you, right? So there is a lot of different projects right now that are trying to figure out how open telemetry works in order to capture all these actions that the agents are executing. You don't have to worry about any of that. So that's the beauty, and I'm going to show you in a little bit. And the last thing, as I mentioned before, so a lot of these microservices or multi-agent systems, right? They need to communicate somehow, right? You can have an agent as a class that you can just initialize and say, run this, and then you run this, and then right? And then you can say, I'm communicating with all of them. I'm doing it in a loop, in a workflow, right? Yeah, you can say that. But this way of communicating is super powerful because you are generating this like conversation context, this chat way to relay messages or work on a problem that is super powerful as well. You can provide, in a conversation, you provide more context, maybe some other new ideas, right? Versus if you just say, execute an action, and if it fails, let's see what's going on, and let's execute it again, and read the error, versus having a conversation about it. It's a little bit different. So with Dapper and Floki, there are specific APIs, as you could see, publish, pops up, and broadcast, like the whole path. That's something that I didn't write, right? Which means that if I deploy my agents as part of a Dapper, let's say, cluster, I can simply just say broadcast to all my agents in the state metadata. That's it, right? So I use that a lot now. It's a way easier to use, in my opinion. And then you can define also the type of messages that you can send. And it uses cloud events schemas by default. So if you're familiar with cloud events, it's a standard, right? GRCP, I think it is, standard, GRCP. So it's super powerful as well because you get additional metadata for every single message that you exchange, right? All right, so just something quick, since we're just 20 minutes into the presentation. I thought it was already 30 minutes. There is this project, and this is more for security research. So I like to start from here. Why? Because that's exactly how I believe I started my career in this field. As I mentioned before, I've been doing cybersecurity, especially on the defense side, and at Microsoft for 4 years doing offense as well, 4 years. And so to me, to dive into something new, it was very important to learn a faster way to process like all this information. So this is, I don't know why I did that. So this is something that I built with Floki, and I'm going to show you what it does in a second. But the idea is that I wanted to define a couple of deterministic workflows initially, just to kind of download papers from ArcSiv, which keeps a lot of the research, I guess, papers that the community publishes and shares with others. And there's an API that you can set and say, for example, I want to focus only on computer science papers, and I would love to look for the concepts of agents or Gen AI and like blue team, red team, offense, defense across all of them, right? And the reason why I built this is because also there was a lot of people in my organization that were sharing emails with like 20 different links with multiple bullet points, and there's no way I'm gonna read that, right? Like, I don't know, I have ADHD, I believe, or I just can't focus in so many different things. Like, I just can't do that. So the only way that I can learn, if I really want to force myself to learn something, is through a podcast, through a way to communicate and just listen while I'm either commuting, while I'm working out. So the idea was to download all the papers, filter all the papers with an LLM, just to make sure that we're capturing the right context. You can capture the summaries of every single paper, and then at the end, we can download all of them, and then start using also LLMs to write a transcript. So every single page is gonna be read, and you tell through a prompt, hey, I would love you to focus on every single page, trying to gather the key concepts of every single page, everything that might be too complex for a regular person, try to break it down and just tell me like if I was 5. And then I would like you to also tell me what the key takeaways of every single page are, right? And try to describe it as if you were just talking to me, right? Explaining it to me. So that was the writing the transcript, and then we started doing the text-to-speech, and this is something that I could do with the company 11 Labs. So you can do for, I think, $20, $20 a month. You can actually do 10 concurrent API calls. So we can just, fan out and then fan in, right? And then we can also generate every single episode. So what does that mean? So I take the transcripts, right? They're pretty much a summary of every single paper. And then I take the summary of the paper itself, because the paper comes with a little summary, and I'm trying to define what that episode, right, would be, and give it a title that is more engaging than just trying to, right, put the title of the papers. It just sucks sometimes. So that's what I do, and then I simply generate the audio, and that's pretty much what we do with what's that one? Yeah, sorry, I can't see what, here it is. And then just write all the episodes to to MP3s, right? So there is already a podcast. Let me see if I can show you here real quick. So if you can sign up. Let's see if we can do this real quick. There you go. Spotify. And there you go. How do we get to the? Let me get a link. Here it is. So put that in there. I think that's the one. There you go. So this is the AI Security Voice podcast. It already has 2 episodes, and there is one more coming today. And it's just pretty much talking about, let me see if I can play, I don't know if I can play the thing through here.
By design effectively.
No.
So addressing these concerns can lead us to a structured
So what I did is I also cloned my voice, which is very easy to do. You have to do like 30 minutes of like recordings, and then you just wait, and the models are trained, fine-tuned on your voice, and then they can generate output. So one of my dreams has been to have a podcast, but I actually say it explicitly in the overview. This is an AI-generated podcast, right? I don't want to lie to anybody. But I figure, you know what? I just put my voice in it, and then just listen to the podcast every day while I work out in the morning. That's it. And there is already, so if we go to this project of Floki, hold on, I need to, 1 second, just make sure I can show you. There you go, and I'll make it bigger. One second. Here it is. So output samples. So we have all the papers that he downloads in here, and then all the episodes at the end are pretty much, my God, the VS Code is terrible. Sorry, there you go. And it's just pretty much what is generated by the system itself. At the end gives me the title, overview, takeaways of the whole paper, and then we also have the index of every single paper, and then the updated index where the LLM says, these are not actually related to cybersecurity, so maybe those, right, you should skip. And then we also have the transcripts. So let me just do this. So in a transcript, you have, for example, my project, the AI security voice. It's actually coming, the project is going to be released this week, where you can define your own character, your own title, or you can have multiple people. So right now, I just said, if you see one person as a host and no participants, just be a one-person podcast. If you see other participants, just start, conversating about every single page, pretty much. And to me, that's a really good job doing it that way. But I felt maybe the first episode just to be me for now. And at some point, it's like a little bit boring. After 20 minutes in, I'm like, all right, I'm tired of listening to myself. But it's but it's pretty cool how you could actually do this for research. So that's part of my security research now. This is, to be honest, even though it might be just a little, I would say maybe funny, but that seriously is, let me present, there you go. That is the first time that I actually automate myself, right, to be honest. Because I've been trying to do that for a long time, because there is so much that I want to do, there's no time. And reading papers was something that just, is too much for me. And this is one way that now, to be honest, every day when I'm just in my office, trying to drink my coffee, I just listen to the podcast, and then I could be doing other things as well, as I mentioned before, and it's fascinating. So anyways, so that was one of the first, I would say, security stuff that I do, and now it's helping me a lot to keep up with all these different things. Now, what are the challenges that we're trying to solve, in my opinion, in cybersecurity, especially from the defensive side, right? This is what everybody wants to build, right? This is something that even when I talk to a few folks internally at Microsoft, right, we're trying to figure out what is the best way to have a system that has the right tools to communicate with the right tables, do NL to KQL, and then figure out how to query all that information, and then just have an analyst that is just waiting for some next steps, maybe for some feedback into what's going on in this incident, right? All the way to have it to do this multi-step, right, or 3 branches type of investigations, right? But let's be realistic, right? If you want to query, KQL, for example, and you are going into this, so who does investigations in this room? There you go, so a couple people. Your query goes from this to this, right? Once you start integrating multiple things, once you start actually trying to, expand the scope sometimes, join it with multiple things, at the end of the day, you have this massive query that for us, that's gold. For a lot of AI also folks that are trying to fine-tune models, figure out how to improve agents, that's gold, because they want to learn from that, or they just want to push those big queries to the system so that they could reference some of that and maybe write a variation of that. But to be honest, I have not seen that succeeding that well, and that's because of the complexities that goes into, for example, something like KQL, to be able to capture multiple things. And when you're thinking about investigation, you start connecting the dots, you start joining nodes, right? And your query is not going to be, in my opinion, sustainable just to be creating this massive thing, right? So agents or models, language models, are not good at that, right? And there's been years already of trying to do NL to KQL, and they're doing a great job, I think, compared to 2-3 years ago, but it's still a big challenge, right? At the moment, I'm not saying that it's going to be forever, but it's just a challenge. So one of the things that I was thinking as part of the research was that technically, even when there is transformation going on, you have this like massive ontology or data model that you're trying to keep up. And when an investigation occurs, your data model and your ontology can just get out of the window too. For example, at Microsoft, when there are investigations, there is multiple data science teams that they bring their own data. So they capture it from multiple places and they bring it into one Custo cluster and they say, I enrich this data, go ahead and hunt on it. Right away, we're like, okay, but what's the schema here? So you have to now learn new schemas in the middle of an investigation. That's not fun. So trying to keep up with that, it's very hard, right? And usually I see these as data transformation and then the hunt, right? And usually we are involved with the hunt, not so much on this area. My team right now that is more focused on AI, let's say enabling autonomy to defend Microsoft, that's my team at the moment. We are now focusing on the ontology, but to support agents and figure out what they can do with it. So something like this, for example, could be, it's possible, the concept. So what's going on in here? In this concept, as you can see the lines from the previous one, so you have the ontology stops over there, and the analyst just receives the ontology. This one is kind of together. Like, can we have a little bit of data transformation and at the same time, right, make it part of the hunt? So what that means is, what if I can build a system that allows me to transform the data in a way that it could also infer its own ontology, right? It can infer its own schema, its own data model. And then since we always think in graphs, because we're trying to connect the dots, trying to connect the evidence, right? We can actually go from the ontology, the data model, right, to a graph. And we can also make the system write the code to go from Custo with the ontology and directly ingest it into a graph. So a couple things that are being, in my opinion, taken care of there. One, you don't have to worry about any other schemas anymore. Like even if I, get dropped into an incident where there is multiple Custo clusters with new schemas, I don't have to worry about that because there is a system that will be able to, right, take a look at it. We'll be able to query maybe the last 5 events and get an idea of like what this ontology could be, like what is the schema of this event. So there is a lot of power into doing that. And then at the end, the analyst, it's someone that could just pretty much interact with the system in natural language. Because now the system was able to understand the intent of the user. It was able to understand the data schemas. It was able to come up with its own ontology. And it was able to write code to generate the graph. So now I can ask questions where the system, with the schema of the graph and the ontology, is capable to write graph queries versus writing these like massive, right, queries where you're trying to do multiple joins. Now, I'm not saying that graphs are better than Custo clusters and all of that. That's not the case because experience as well, by doing this, is crazy if you rely on a graph database as your massive database, so you're trying to migrate a lot of things from Custo to a graph database. It's not going to scale later. But what I love about this is that it's kind of like a more local view of your environment. And if I care about only 2% of my environment for now because I'm trying to start my investigation, I'm okay graphing that 2%, right? I'm okay doing that. Graphing the whole world, it's a total different challenge, right? But this is super useful because you can actually dive into, even make the model think, even in graphs, for example, right? Like the next question that you have during the investigation, you could say, I want you to connect a user that might have been added to a group and tell me how that group is related to other resources in the environment. You can write a Cypher query or a Gremlin query for those that use Tinkerpop, for example. And those are easier to even understand and even explain in natural language. So just think about that, right? How powerful that could be, right? So at the end, right, you have all of these security platforms with all this different information. It doesn't matter if you even add things such as attack paths from like Bloodhound, for example, or any other attack path management system. You can integrate that and say, hey, can you just add it to the ontology, right? Can you just connect that thing with my activity data and then be able to traverse the graph, right? Now, one thing that is very interesting to me is that when you traverse the graph with an agent and you ask the agent to plan, it's really good at saying, oh, I found X, and I can connect it to Y and Z, and I can just go like this, right? But when you ask it for a plan, it usually says, find suspicious activity. To me, what does that mean? How do I find suspicious activity, right? So at that point, to me, this effort, it's a local view of your graph and posture. But if you want to identify anomalies, you have to look at it from a global view, right? So the efforts right now, for example, in the team, in general, and this is not new, there's a lot of people that have been doing that already, so that's what, I can share it. But we're trying to figure out what it means to have a global view of a graph, and how much time it takes to train a model, right, to identify those anomalies. We're starting from a small environment, and to me, later, that will be an input for the agent. So in the plan, when the agent says, let's find anomalies, it would just interact with that tool and say, hey, I have this entity, and I would love to know what the score is from an anomaly perspective, right? So that's how you integrate the global view and the local view. This is pure local view, very scoped, and super useful for those, for example, that are pretty junior into investigating, or even in the company itself. Maybe you are super like an expert in your topic, but the moment you go into a new organization, you have to learn one more time what all of these schemas and data and everything. As I mentioned before, investigations, you run into like new data sets all the time, right? Something like this would help. So how does that work? This is something that I put together. It's kind of a little messy, but hopefully it makes sense. And so I can take you from here then to the code, to Flocky, and I can explain certain areas into how I'm using the concepts of, the fan out, fan in, chaining, loops, and everything all together, running a workflow with Flocky and Dapper, right? So we start by taking the user message, the question. I'm trying to look for files being created in my environment. Next step, let's not plan anything yet. Why? Because we're trying to go from left to right, right? Left meaning the closest to the data, closest to the environment, right? First question I always have is, if you're looking for file creations, can we figure out what are the file creation data sets? Like, where do I go to look for that data? That's a valid question. And a lot of people can answer that, like truly answer that. Even at Microsoft, if you ask where the signing log data is, you will be like, wait, are you talking about something that customers can see or something that we can see? Is this something that exists in this environment? It's just a mess, right? So the idea is that we can index a lot of these schemas, and the more schemas people bring to the conversation, it's totally fine. Just bring all the schemas that you have, and then be able to take all of those, create an index, so be able to send those to a vector database, try to do query decomposition, where you can take the question or the multiple sentence question that a user might have, break it down into small pieces, and do like a multi-hop type of RAG, right? Retrieval augmented generation, where you could identify similar schemas, right, related to the query, right? So we do that, and then we get the relevant schemas, and then we also use an LLM to inspect all the schemas. So that's what that one does. So once you do multi-hop, you're going to end up with multiple schemas. So at the end, you have to do another pass and figure out which ones are the top that will support the intent of the user, right? Then we can do some, fan out, where the idea here is that now that I know what data I need to collect and where I can collect it from, I can actually execute queries, not to do the super crazy queries, but very basic, let's say KQL, or SQL or any other Splunk or anything. Very basic queries just to say, based on the schema, if you want to look for file creations, we might look for event 11 in Sysmon for on-prem, or we can look at the file creation events of like MDE, right, in Defender. Let's just capture the time that you're looking for, and let's go to the data set, and let's just retrieve maybe the top 500 events, right? So that's like one way that we do this, so we can create a couple of files, and then we actually ask an LLM to also generate the ontology based on the schemas, right? So as all of this is happening, we can execute the other task where we say you have all these five schemas from different tables, and I want you to generate a graph ontology with this. So to me, that's very powerful because you're not giving it 500 times 4 events to an LLM. You're just giving it schemas, right? So even if you have 10 schemas, that thing is going to fit in one prompt, right? So the idea is like how you can start create this structure of, based on the schemas that I'm working with, what are the top entities and what relationships can I define in these schemas? And then based on that, you could actually make it write code for you. Right now, of course, it's very basic Python code, but you can make it, of course, better. And the idea would say, look, I have the schema, which means that we know how the events are going to be processed. And we also now have a graph ontology. So can we write some code that would allow us to translate that into a graph, right? And that, of course, once again, if you do it over hundreds of thousands, it's going to take time. But if you do it in a very scoped engagement, it's going to be super cool to have all of that ready. And then it goes to a graph database. Now the user can actually ask the question again or simply let its first question just to kind of be ready to be answered. And now that the system has an ontology, right, based on the schemas, now we can also generate graph queries, right? So at the end, you can actually have this system where every time someone wants to investigate something, you can kick off the indexing, right? Because every question is going to be different. Most of them will be different because you might be looking for, all right, I already did file creation. Let's look into process that maybe created that thing. Let's see who accessed that thing, right? Let's see what network connections probably occur. All of that, as you all know, has different tables, different schemas, right? They might have some similar fields, and that's how you kind of like show the model, like how they could be connected. But that's something that you can do, and you can use this as an on-demand type of tool. And it's pretty useful. Yeah, very helpful to do it. So let's see if we can do this. I'm going to try to make this better because I don't like to see all these things. Hopefully you guys can see. Let me just make it a little. All right. So let me show you first, I guess, maybe the basics would be Floki first. I'm going to close some of these things. Let me show you what a workflow actually kind of looks like in Dapr. Let me see 1 second. For example, this is the way how a Dapr workflow kind of looks like, where you simply like import your libraries. You can initialize the workflow, and you can use decorators to say this is my workflow. And inside, I'm going to simply run the context call activity, and simply run other functions that are in the same script that have the decorator activity. That's pretty much it, right? And then you can, inside of the workflow, you can do your basic tasks chaining, which is what the yield it's for. So yield will kind of wait until it's done and then move to the next one and the next one. But if you take the yield, it's going to just run async. This is so basic, but at the same time, I really encourage you to go and figure out how to do that with other libraries. that are doing it for AI. I'm not saying for this type of things. And now the value of this, once again, is that every single task that is being executed is wrapped around, right, the concept of Dapr, the sidecars, the services underneath, which are capturing all the telemetry and all of that. So what does that mean? For example, if I go to, as I mentioned before, let me make this bigger. Dapr, when you deploy it locally, you can actually have a Docker container that gets deployed automatically that is going to run Zipkin. And Zipkin actually captures the open telemetry from Dapr. And then you can actually see, for example, the execution. Let me just see if I can find another one. Probably, nope. Let's see. There you go. Look, so my demo failed earlier, which is fine, but at least I have proof that, how do we do this? There you go. So automatically, you can see in here that you get this like out of the box, right? And there are a couple services that are trying to do this, but you have to either, one, pay for it, or you have to send your data to a cloud service. And this is something that you do with Pydantic, for example. If you use Pydantic AI, you can use this amazing locksmith, I think it's called, service, where you can get open telemetry from your applications, AI applications, but all your data goes out there, right? This one in your computer, and you get a similar feeling. And you can actually see exactly, like what was, for example, the error. Let me show you here. One, I like how it kind of shows you the sequence of things, right? Like when is something being executed. For example, the query generation, you can see that those 3 were executed as a fan out, right? Those 3 queries, but then this one, I guess, took forever. And here's an error here. So, I was wondering what happened with this one. So I know that it failed on my main workflow, and this is not a message. Oh, okay, a variable that I'm using to pass to my my tasks in the workflow. But anyways, that's what I mean by something like this. When you look at it, is very simple, right? But there is a lot of things going on underneath that, to me, are super powerful when you're trying to monitor what the agent is doing or not, right? Now, what is the difference with, what does, Flocky does? So I can take the same. It's going to look kind of like the same. So this is Flocky. It looks pretty much the same. but the difference with Flocky is that Dapr only allows you to define a workflow, a function, and instead of a task, it was called an activity, right? That's called an activity, right? Activity. And all you can execute is just Python functions, right? With Flocky, I introduced the concept of a task. You can see how it changed, right? And is that a good size for you guys in the back? Yeah? Okay. So the difference with a task and an activity is that with Flocky, you can take a task and you can pass a description of the task, and that will be a prompt. Underneath, there is already one LLM client that is being initialized, and by default, it's just OpenAI, right? Clients. But you can set it up to whatever you want. There's actually a parameter in the task that you can use to define the prompt and to define the LLM, or to define the agent. So you can attach an agent also to the task itself, right? So that's the concepts of Flocky, how he creates this wrapper around Dapper activities and makes it so easy just to create a, so let me show you what that means. For example, if you go to Dapper and you want to call, for example, like OpenAI, right? You will have to do this, which is fine, right? Like, it's okay to import OpenAI, initialize it, and then put a couple messages, and then try to get the characters, right? But if we go to Flocky, and this is all in the repo, by the way, you can go to the cookbook, workflows and basic, And this is what it looks like in Flocky. So in this case, I'm saying, pick a random character from the Lord of the Rings. I'm a big fan. And then respond with the character's name only. That's it. And underneath, that's going to be taken by an LLM client, send it over, right, retrieve it, and then can I show you what's going on? And one thing that I'm not showing in here, or maybe I do, oh, here it is. One thing that you can do also with Flocky is something like this. Look how small that thing is. So you can have a workflow where you can only have, let's say, one task with its own prompt. The variables, I guess, the parameters or arguments of the function are going to also be used to be substituted inside of the prompt, for example. So if I call this function with name, in this case I was calling it with Scooby-Doo, then the prompt is gonna be run with that, right? Who was Scooby-Doo, right? And the second thing is that if you define a pydantic object or class as a schema, you can pass it to the types, the return type, and then the task is going to know, oh, okay, you want me to do structure, output, or be able to use a tool call from OpenAI to be able to receive a structure output, right? So that's something that we do in Flocky, and you can just do it in a simple way like this. And at the end, every single output of every single task must be a dictionary. So at the end of the day, what Flocky does underneath, it takes that pydantic object, it receives the structure output, it validates it, and then it just model dump, and it just exports a dictionary, right? So all of that, instead of typing it over, you can just do it right like that. All right, so that gives you a 101 into how Flocky operates. And another thing that we can do, let me see if I can maybe show you here, and then we dive into the other example. Let me see if I can do this. I don't know why there you go, that's what I was looking for. So with Flocky, we can actually do, so if we go to cookbook, we go to workflows, and there is actually very basic, and it kind of gives you the idea of how this works. And by the way, the doc to podcast is also here, the basic idea, but then I have another project that takes it to the next level. So the idea with Flocky is that when you work with Dapr, for example, and you want to define your services, right? You define services that are exposed with a fast API server like this in Dapr, right? You can actually build an application and then simply expose it, right, with an API. And Dapr has an extension for all of that. So what I did is I just took my agent, the basic one that was telling me the weather and all these things, and I just exposed it as a service, just one wrapper, very easy to do, so I'm gonna show you right now. But this is how you can run multi agents, very easily, right? Trying to define the Dapr ports, the basic port for the application, and let me show you what that actually looks like. So if I open services, and I go to the ELF and the app, this is what the app looks like, for example, where all it is doing is initializing the agent, right? And give it your typical goals and instructions and everything you want. And then at the end, you can wrap it around this Dapr agent service, which exposes all the Dapr connectors and components, right? And now you're ready to start exchanging messages and all of that. So that's how easy it is to define just one agent as a service, and it's already working. And just to do a very basic one here, it's gonna be the, let me see how we can, once again. So we're gonna use the workflow services, workflow LLM. All right, so let's use the workflow LLM. So what that means is that the way how this workflow works is that it's going to know how many agents are, it's gonna know the goals of the agents, and then every single question is gonna be routed through this manager agent, and it's going to decide who speaks next. That's something that you see in AutoGen, in other frameworks, But in this case, it's all being done with Dapr. And if you want to know how that works, you can go to the source, Flocky, agent, workflows, LLM, and it pretty much kind of like, for example, this is the prompt, one of the prompts in here. No prompts, what's inside? So the LLM workflow, it just processes the input, it adds a message to the whole history of every single agent, broadcasts the message, and then it selects the next speaker, it triggers the next speaker, and this is something that also is super powerful with Dapper and Flocky, where you could actually, wait for an external event. So this is where you could also add the human in the loop. So when you're doing, for example, a security investigation or using the system that I mentioned before, it's something where you could say, is the ontology okay? And then just wait, right? Or is this query the right one? Is this, are these schemas what you were actually thinking of, right? From like what schemas make sense to query data for. So that this is so simple on like how you could just generate an event. As long as the event comes in, it's gonna be waiting, right? And that event can come from multiple services, right? You can do it locally, or you can just have an API or being connected to a service. All right, and then just to finish, we can just do a quick, let me run the other one so we can finish the presentation here. So this is the incident triage, let's say like agents. And this is what I was showing you in the slide, where there is a couple agents, and there is an agent that is my SOC manager agent. And if I go to the main workflow of the agent, we can actually walk through this real quick. And it's going to be released also this weekend. This is pretty much what I was telling you about. So this workflow is going to initiate, it's going to capture any input. It's going to be waiting for any type of, this could be a question of like, hey, I want to query for any type of file creation events in my environment. And then this is going to directly process the input just to kind of say, all right, so I'm going to take your message, I'm going to put it in a format that I can exchange, I can send it to everybody in the multi-agent collaboration team. And then I'm going to execute a child workflow. So this is also great because you could actually keep your main workflow very kind of simple, and you can just define multiple workflows with Flocky. And what this one does, if I go to that one, so I go to workflows and retrieve schemas, workflow, it's very, very easy to read. It's reading all the schemas, it's creating the documents, so it's taking all of them. It's going to be indexing all the documents, and it's going to perform the query decomposition. And then at the end, it's going to just simply start generating the relevant, it's going to be trying to figure out what are the relevant schemas to be able to investigate this incident. And then at the end, it's going to filter the schemas and simply return that. So with this basic workflow, we are already trying to identify what is the right data set to use in order to query or do an investigation, right? And the way how you run this, I'm going to do it right now. It's potentially going to break because it keeps breaking a couple of things. So what I do is I go to my demos, incident triage, and there is a Dapr YAML file, which just has a basic way how to define every single agent. And I can just do Dapr, run that that F, and dot. And let's put all of this all the way up. And what this is doing, as you can see, it's, so this is what I love about Dapr. Dapr also captures your state. So I stopped it before coming down from my room. So it's trying to get back to where it was. That's also one of the benefits. It kind of like plays it from where it stopped. And now you can see that it tried to do that, but then it stopped, and now all the agents, the two agents that I have are just reporting back, saying, hey, I'm alive, which is also by default, something that I didn't build. As long as I wrap it around the services, you can do it. But let me just stop it. And then every single Dapper project comes with a Redis, and you can use Redis Insights in order to see what's going on. And I'm going to delete all of this, right? So we back that. There's nothing in there. I'm going to start this again. And let me show you here, for example. In here is just my graph expert is called Graphius. And my SOC manager is here, so it's all there. And then my threat intelligence person is Legolas, like log and Legolas. And then it's just there waiting, right? So now what I can do is I can just interact this as if it was just as any API. So I'm going to make this bigger. And I'm just saying a file was involved in an alert, and it is now in several endpoints. I want to know more about files being created, right? So I'm just giving it my task as if I was just calling an API. And I'm just going to give it this, even though the time is wrong, it might not pick the right queries. But if I'm going to send that, and I go here, and make this smaller. This one is already embedding. There is generating embeddings of the schemas, and it's just going over the whole process, right, of identifying what schemas are relevant to use for the investigation based on my intent on my query. And then it's just kind of going over every single step. Right now, it's trying to come up with the queries that it needs to execute. Some of them will fail, once again, because of the time. Right now, it was able to capture the schema of, I think this is file creation. No, this is file stream, for example. So it was able to pick the file stream schema, but then I can just simply have a loop that says, think harder. It's now file streams. You have to look for the file creations. And but this is still pretty good, because if I go to the schemas, for example, I give it a ton of schemas. And it's just like, multiple things, not only files. It's just Azure stuff and Defender, and it was able to at least capture here it is, something. A file was involved in an alert. Then Graphius, it's saying he's going to run this query, Neo4j query for file creation. The file was created by SVC host with this GUID. And then Graphius says, yeah, there you go. So that's pretty cool, right? So we went from the process of running a deterministic workflow just to define what it is that we need for this basic hunt. And now that we have the data available and things in a graph, then we can simply make the agents generate their own graph queries and simply interact with that. And Graphius had the context of being a graph expert. So the SOC manager says, all right, you will be the one executing that query, right? And that's it. So you can do a lot of this with Flocky, and as you could see, integrating it with very complex workflows, right? To be able to do this, if you put this at scale, it's very cool. So anyways, this is Flocky. You will be able to get some stickers if you wanted to. If not, it's fine. Yeah, so that's Flocky. Thank you very much for your time, and sorry we went a couple extra minutes, but I appreciate it. Thank you.